Good day, I'm Maile Matsiba. Welcome back to our channel. We continue yet again with our 2017 study guide section 2. We're looking at example 2.7.5, which says a mixture of liquids A and B contains 40% A and 60% B. That is like the mass fraction of A is 0.4 and the mass fraction of B is 0.6. And the SG of A is 1.4 and the SG of B is 2.1. Now it says assume that the liquids form an ideal mixture and calculate the SG of the mixture. So now with that said, for us to answer this question, we just need to put together all the information that we have. For instance, now we know that if the SG of A is 1.4, then the density of A is equals to 1.4 kilograms per liter, and the density of B is equals to 2.1 kilograms per liter. Well, that we get from the SGs. Now, moving forward, our step 1 would say, step 1, calculate the mass of each liquid. Calculate the mass of each liquid. With that said, we know that if we have more mass fractions and then we need to calculate the masses, we're going to need a basis. And the basis that we're going to be using, as used in the study guide, we're going to choose a basis of 1 kilograms mixture. Now, with the 1 kilogram mixture, therefore, if the mixture is 1 kilograms, the mass of A is equals to 0.4, which is the mass fraction, multiplied by 1 kilograms, which is the mass of the whole solution. Now that gives us 0.4 kilograms, and then the mass of B is equals to 0.6, which is the mass fraction of B, multiplied by 1 kilograms, which is the mass of the total solution, and that gives us 0.6 kilograms of B. Now that is our first step. Now step 2, we need to calculate the volume. You can just say, now that we have the mass and they want the density, we can calculate the volume. Calculate the volume of each liquid. Now we know that density is equals to mass all over volume, right? Now we can say that the volume of A is equals to just some simple and very known rearrangement arithmetics on some high school mathematics. We know that the mass of A is going to be the volume of A is going to be the mass of A all over the density of A. That means it's going to be, sorry, let me just put this properly here so it becomes clearly visible. So the mass of A, we calculated to be 0.4 kilograms, and the density of A, we already found it to be 1.4 kilograms per liter. Now, the kilograms fall off, we get left with 0.28571 liters of A. Now that is our A, so we can continue, can go further to say, let me just get a new page here. We can continue further to say the volume, sorry about that, let me just put it properly. The volume of B is equals to the mass of B all over the density of B. That means, well, the mass of B we calculated it from here to be 0.6 kilograms. You can see it here. So it's 0.6 kilograms all over. The density of B we calculated to be 2.1 kilograms per liter. So it's 2.1 kilograms per liter. Now the answer gives us 0.28571 liters of B. Now we have the volumes of both A and B, and the question says that they need the SG of the mixture, which is the density, or the real density as they call it. So if we have, let me just bring this here just to show you, if we have both the masses, or rather the volume and the masses of each of the compound, then we can actually calculate the total volume and then calculate the density from the individual, or rather from the combined volumes. Okay, let me just put it in writing. Let me just say the total volume equals to, let me just put it here, volume of the mixture is equals to 0.28571 liters plus 0.28571 liters. Now that gives us 0.57143 liters. So this is actually the volume of the mixture. And remember that we already have the mass of the mixture. And we know that the density of the mixture is actually equals to the mass of the mixture all over the volume of the mixture. This is a standard equation. Now with that said, we can use the information we have. We know that the mass of the mixture, as we already chose the basis, is actually 1 kilograms. So in the mass we have 1 kilograms all over. We know the volume of the mixture, we calculated it, both the individual volumes of the two liquids. The total of it is 0.57143 liters. So we know that is 0.5. Let me just put the kg properly so it gets visible. 0.57143 liters. Now the density becomes 1.750 kilograms per liter. Now with that said, that is actually our density, and that is actually our SG. So we can just, for surety's sake, we can say SG of mixture is equals to 1.75, and that is actually how to calculate, or how to solve this question, and or calculate the SG of the mixture, and that is the SG is 1.75. So thank you guys for your time, and I hope we meet again on our next video.